Lunch or wonderful break. And for those of you online, I hope you had a nice little break as well. I'm very excited to welcome you back for our next presentation from Dan Yeaw, showing up. Showing up. There was a pause. Showing up for Python and GNOME. Take it away.
Hey everyone, I'm so excited to be talking about showing up for Python and GNOME. So for my day job, I work at Ford Motor Company in functional safety, which really helps ensure complex software is safe for customers and doesn't malfunction and cause harm. And as part of this, we model like the behavior and structure and requirements of a system as part of the rigor we apply to a system design. About 6 years ago, I started getting involved in a Python GTK app called GAFOR with a goal of being able to do the systems modeling with an open source tool. And now it's a GNOME Circle app for doing SysML and UML modeling. And then I also got involved in Michigan Python and started hosting that to learn and collaborate about Python where I live in Michigan. And then you start getting involved in like the ecosystem around you a little bit to help fix things going on. So I also contribute to GVS build to help fix pain points with building GTK and Windows. And over the last year, I've gotten more involved in PyGObject, which is the GNOME Python. And that's what this talk will be about, kind of the journey we've been on there. So first, I'm going to talk about something totally unrelated. Let's talk about Pokemon. So my son is really into Pokemon. He's 10 years old, all the video games, movies, Pokemon, trading card games, and he can figure out how to make, with a little help, how to make a simple app and game using Python. And right now he's trying to work on a Pokédex. And it's so cool to see people that are really deeply interested in things and get deep in their interests and see those different kind of interests flourish. And I think that's where really like Python stands. It's easy to learn, but also kind of a hard language to master. It scales with your skill set, and it's also, that's what makes it such like an important language for our ecosystem in GNOME. It's used by students and researchers and non-professional programmers. It's used by artists and data scientists, web developers, systems engineers, even astronomers. And I think right now with Builder, Workbench, Combalache, Flatpak, it has never been easier to build an app for GNOME. And I think this is kind of the big tent we need in our community to make room for people of all walks to come and easily build small apps for our ecosystem and geek out on their interests for them. So we need to make sure the GNOME experience lives up to this so that they can come and join our community. So PyGObject, this is Python in GNOME. It is a successor to what was called PyGTK that James Henstrich started in 1998, and it uses PyObject introspection directly to allow you to build GNOME apps with Python. If you see the patterns and the app icons here, they kind of reflect those deep interests I was talking about. So it includes things like art and modeling and graphing and music. There's genealogy, a manga app, classic gaming, scientific reports. And I think that really reflects kind of what people are using Python for. In December 2022, Emmanuele Bassi wrote a blog post called On PyGObject with a call to action to get more involved to help Christoph Reiter, the maintainer of the library. He went through 3 large use cases of features missing in PyGObject, which really made it hard for him to recommend people use it. This included typed instances for things like GTK expressions, render nodes, and events. These foundational types were not supported in Python in GNOME since they weren't based on GObjects. The second thing was the base wrapper for GObject itself is written in Python instead of using GObject introspection. This means that constructing and disposing of objects can be difficult because PyGObject doesn't automatically get access to the functions for doing these operations. And finally, the documentation was spread everywhere. and a lot of it wasn't updated for GTK4. You can see the pattern in this commit history. Although it isn't the only or most important indicator of community health, major contributors like Simon Feltman, John Palmieri, and Martin Pitt left the project, which is kind of a natural part of open source. And Christoph really kept the fires burning late into the nights, but he was also working on other important open source projects like MSys2. PyGObject was mostly idling along with absolutely necessary changes only. And this was also a time where the overall ecosystem was making a lot of changes, like GTK4 being released. And you could see kind of the downward trend there over time. Major open source projects really need a contribution funnel to get people involved. This community building requires many hands to get involved to help newcomers triage issues, review contributions, answer questions, and provide support. Unfortunately, it is all too common for one person trying to hold it all together, even for multiple projects. This is also a catch-22, that one person who has so little time to hold and is trying to hold everything together only has limited time to manage those issues that are raised or each merge request submitted, and it's extra work and burden on them. It doesn't feel welcoming to new people if they show up to help and their contributions dead rot. And it's often, if you do show up to contribute and it doesn't feel welcoming, then you go other places where you feel like your work will make more of a difference. Since GNOME is a whole project and developer access is across the entire project, this also adds an extra layer of complexity to try to figure out how to get through. For an under-maintained project, it kind of feels like GNOME is this walled city, and you're at a gate trying to knock, and there's no one there. Wow. So the GNOME project handbook, which was released at the end of January, is so good. It is such a special resource to document to everyone how to get involved and sets expectations. Really a huge shout out to all the team that was involved in creating that. Since GNOME as a project is made up of volunteers and individuals paid by companies with their own priorities, it can be often difficult to shift resources to help out on each part of the ecosystem. Also, Emmanuele shouldn't have to write a blog post asking for people to help to get involved. There may be an opportunity for the GNOME Foundation or other community members here to track the health of the ecosystem of key GNOME projects using metrics, and then provide community building support for those that are starting to have challenges to help them out before it becomes an issue. Let's switch gears a bit. I want to talk about the state of PyGObject because we've made some huge improvements in the last year. Let's start with the basics. A clean issue and merge request backlog is important for a thriving community. We made some major inroads in the last year to reduce the total open issues and merge request counts. Although we haven't quite gotten all the way to the subset we really are going to work on, getting issues in the 100 to 200 range is something that contributors can get their head around, and much more than this can feel kind of overwhelming. The next thing is fundamental types. GObject is the base type system and object class and used for most of GTK and related libraries. Types are the fundamental part of a programming language like C to translate a type like a char to the machine architecture with a minimum size like 8 bits and whatever the maximum size is. glib provides a type system for GTK and related libraries. Most of these types are fundamental types that are instantiated by glib automatically, like gchar. And most objects are created by inheriting from GObject to get all the things that come with a GObject. So you get memory management, properties like getters and setters, and construction and deconstruction of instances. However, not every piece of data used in GTK application needs all that. So other fundamental types are created by GTK through defining a class and instance structure. Up until recently, PyGObject didn't support making use of these fundamental types for data in your programs like expressions, render nodes, and events. So let's jump into an example. If you're not familiar with Workbench, it is this great app for learning and prototyping GNOME apps in Vala, Python, Rust, and JavaScript. I highly recommend it. It's really good. Here you can see the column view example. Column view was added in GTK to make it easier, GTK4, as an easier way to create a table of data. Here's a list of books with title, author, and year. You can sort the columns by clicking on the column header and also select a row, which is shown in the light blue. For GA4, I would like to integrate a table view for that model-based systems engineering diagrams for doing analysis. So I really want to make use of column view. As we saw in the column view, being able to click on a column header and sort it is really important. It's kind of expected functionality. So for strings, you want to sort them from A to Z, and for numbers, sort them low to high or high to low. Since this is such a common use case, GTK provides a straightforward way to enable this sorting with something called an expression. And we use a certain type called a property expression. An expression is a way to describe a reference to a value, and a property expression does what it sounds like. It provides a property value in an expression. This is different than normal property bindings because the object which is being bound doesn't have to exist when the expression is created. The expression is called this. It references an item which has a property. The expression is getting the value of this property. It is still possible to sort columns without expressions, but it takes a lot of work. Let's see how you had to use to do this in Python. First, we get some objects from Workbench, because this example was from Workbench. So it gets a column view and 3 columns, which were defined in a builder UI file. Next, we create an empty function called the model function using a lambda. We need to create a tree model, a tree sorter, a sorter model, and then a selection which we set as the model for the column view. The model is a GIO data model. We make use of GTK by instantiating the tree list model, the tree list row sorter, sort list model, and a single selection. Wow, okay. Now we need to write our own logic to actually do the sorting. The first function we define is for sorting strings. Like for the title and author columns, this function takes 2 objects and the column. It then gets both values using a get adder to get an attribute and sets them to lowercase so that the case of the string doesn't impact the order when it's sorted. Then it compares the first character of the string based on the Unicode ordinal value of the character. If they're the same, then it compares the next character and so on. If A is larger than B, then the function returns 1, and if B is larger than A, then it returns -1. The integer sorting function works the same, except no lowercase is needed because they're integers and they're directly compared. Finally, we set the sorter of each column using custom sorters that we created. We did it. We created our sorters without expressions, but that was quite a lot of work to do that. So now we have implemented fundamental types in PyGObject, which fixes this use case number 1 from the on PyGObject blog post. The original work on this started in 2010, and Arjan Molenaar brushed it off and brought it home this year. Now we can make use of expressions for our logic. Here we create 3 property expressions, pass in our book class. We pass in none because we don't need to evaluate an extra expression, and then the column name. Finally, we set the sorter for each column to string sorters for the title and author columns, and numeric sorters for the year column, and pass on the property expression we just created. Said another way, the sorter for each column is bound to the property of the book for that column. The addition of fundamental types is such a large improvement, and this is such a contribution that was made just recently by Arjan. Centralizing docs. So we used to have PyGObject docs hosted on Read the Docs, and that's very common for Python projects. Rafael Mardohai also had a really nice PyGObject guide, which was a tutorial for Python with GTK, and that was also based on the Python GTK 3 tutorial by Sebastian Polsterl. We worked with the communities to convert the projects from the GNU free documentation license to LGPL, And then we merged the tutorials with the other docs and moved them to a more official PyGObject.gnome.org subdomain. Next, I'll talk about packaging and development environment improvements. The Python project configuration in setup.py files was the standard for a very long time, and it is still pretty widely adopted. When Python first developed its tooling for building projects, distutils, which was in the standard library, was the answer. As time went on, setup tools gained popularity to add some features on top of distutils. Both use the concept of a setup.py file that project maintainers executed to build and install the software. The downfall of this is there wasn't really a good way to declare the dependencies a project needs without running the setup.py file itself. The main Python install tool pip was then executing arbitrary code just for pip to see the dependencies or to install a package. An advantage of this was that as a project maintainer, setup.py is just a Python file, so you could put any custom build stuff you wanted in it. But let's move to a more modern alternative where we can break up our build steps to install the build system and then execute the build as a separate step. Mason is the standard build system used by GNOME projects. It is easy to use, fast, and powerful. Mason Python implements the Python build system hooks, enabling Python build front ends such as pip and a tool called build to build and install Python packages based on Mason build definitions. Since we were separating the steps anyway when moving away from setup.py, we use Mason Python to also build PyGObject. Other popular Python libraries like NumPy and SciPy have already moved to use Mason Python, and PyCairo, the Python bindings for Cairo, is also planning on doing so soon. I think this really fills a nice niche for Python projects that also have to compile or build other languages like C. Here's a portion of what we're using to replace setup.py, a pyproject.toml file that we use for the build settings. The parts in brackets are the section for Mason Python arguments in the build system, and in each section are the key value pairs for setup options, the build backend, and build dependencies. Nice, so now we can build PyGObject like any other GNOME project. When someone says Python packaging, they could mean also a lot of different things. So it could be environment management, which is mostly things like virtual environments. That's in the purple. It could be package management, which is in blue. Python version management of installing multiple versions of Python is in gray. Package building is in yellow, and package publishing is in red. Mason Python takes care of the yellow since it's a build tool. We decided to add PDM to the mix, which takes care of a lot of the other areas to make it easy to contribute to the project, and still works with Mason Python. It manages dependency installation, including resolving and locking dependency versions. It helps set up virtual environments and publishing new versions to the Python package index called PyPI. One of the other tools in the blue called pipex is also really nice for installing isolated Python tools as long as you have the other system dependencies you need for PyGObject. You can install PDM with pipex, grab the PyGObject source, and then run PDM install to get a complete working environment. We've also been working on modernizing the API docs. Just like many other libraries have upgraded from GTK-doc to GI-docgen, PyGObject also recently made the switch. GI-docgen reuses the introspection data generated by GObject-based libraries to generate the API references of these libraries. Previously, we were using PGI-docgen. PGI is actually this cool project by Christoph to create Python bindings without C code, and PGI-docgen was then able to create the GIR docs and create a Sphinx website from them. But we decided to move on to a more standard approach. Previously missing documentation, like for GTK template, is now available, and because we are using the introspection data directly, and it's less maintenance going forward. This is kind of a minor change. but we also renamed the primary branch from master to main earlier in the year, and this improves standardization and us being inclusive with other GNOME projects. Async I/O. This is another really big change. Async I/O is a means to cooperatively multitask. It gives a feeling of concurrency despite using a single thread in a single process. The central feature of async I/O, called coroutines, can be scheduled concurrently, but they don't actually run at the same time. This can provide a large speed up for cases where the program is waiting on something that's slower than the program is to execute. For example, if a program needs to go out and fetch some information from the network or from some complex database query, it can schedule other things to happen while it is waiting for the data to return. A Nintendo Switch. So I wanted to give another example with my kids. So they really like playing Switch. And so they're always like, hey, Dad, come play Super Mario Kart with me or Super Smash Brothers. But boy, do they take so long to get going actually playing the game. They'll sit and watch like the previews of the new games coming out. Then they'll like watch the opening credits of the game. Then they'll customize their characters, and it's like 15 minutes before you even start playing. So I just can't do it. It's also not like a good way for me to like interact with them because they're like glued to watching whatever like preview is or something. So I'll often get my phone out, browse Mastodon, see what's new in the open source projects while they're doing that. This is kind of how async I/O works. It allows us to schedule tasks in coroutines like playing a video game and looking at my phone and switch between them. I'm not actually doing them at the same time, but I am getting more work done that I wanted to do. This is a simple hello world example of using async I/O. I thought it would help kind of show how we do it in Python first, and then I'll show how we're using it in PyGObject. First, we import async I/O. Next, we define a hello coroutine, which is really this normal function definition, but it has this async keyword in front. We print hello. Next, we use the wait keyword to let another coroutine run to sleep for 1 second. And finally, after that runs, we print world. We also define a second coroutine called main. This uses async.gather to schedule the hello coroutine to be run twice concurrently as 2 tasks. When this executes, it prints hello, then runs sleep, and since that's async io.sleep, it's non-blocking. And then there is another call of hello scheduled because we're waiting for the sleep to happen, so it prints hello again. Once the sleep coroutine finishes, it resumes printing hello, it resumes printing world twice. We've had some async support in the Python landscape for GNOME in the past. So there was 2 options. One's called gbulb, and another one's called async async glib is the other library. So here you can see it was possible to import async IO and gbulb and tie async IO to the glib event loop. This is useful for GUI applications because if you have something long running, you don't want to block the GUI application because because you're waiting for something to return. And that would make your app feel unresponsive. This is kind of a heavy implementation that implements most async IO functions on top of glib. There was also another library, as I was mentioning, called async IO glib. Gbulb dispatches async IO callbacks directly from the glib main loop. In contrast, async IO glib iterates the glib main loop until an async IO event is ready, and then has async IO event loop dispatch the event. In this example, we run glib.install function, get the async IO loop, and then run the loop while passing in the GTK app. One disadvantage of both gbulb and async IO glib is that they don't allow you to await GIO asynchronous results. GIO is a library for things like general purpose IO and networking. Access to many of these things can be slower than your app, and it is really this great use case to use async IO. After 2 years, Benjamin Berg finished an initial implementation of async IO integration with PyGObject, which was just merged this week, just in time. So now we have Python async IO await for GIO async results. This approach uses the gmain loop to drive the event loop and allows us to await GIO async functions. In this example, we're going to walk through this example listing the names that are available on the dbus. Dbus allows inter-process communication to allow applications to talk to each other. After doing some imports, which I didn't show here, we define a coroutine called idle test. Since GIO supports asynchronous calls, we await getting the system bus by calling gio.bus_get and passing in the bus type. Now that we have the system bus, we call the dbus while passing in the bus name, the object path, and the interface name, and the method we want to use, and various other parameters. Finally, we need a bit of boilerplate to get things going. We use the glib event loop policy, which is used to get or set event loops. We then set the policy with async IO, which wires up the gmain loop to drive the event loop. We then get the event loop and tell the program to run the idle test coroutine until it's complete. Our program then prints out the names from dbus, and we have successfully awaited an async result. Wow, async IO directly in PyGObject. Yeah, it's really exciting. Let's talk a little bit about the future. Wheels for Windows. So for security reasons, Python 3.8 stopped automatically loading DLLs on the path of Windows. Many libraries, including PyGObject, previously depended on this behavior. If you build GTK on Windows using GVS build or with MS Visual C directly, you don't end up with a working PyGObject without manually loading DLLs in your program or patching PyGObject itself. We have discussed options to fix this, and there hasn't been much excitement about adding a DLL search routine in PyGObject startup code, and we're still talking about options. But a wheel format allows DLLs to be bundled along the side of the PyGObject library, and then they're automatically loaded. A wheel is Python's binary format for distributing a Python library. This would also significantly improve install time as well, since users can directly install a precompiled version of a library like PyGObject instead of compiling it during the installation. We should also consider building wheels for the other platforms as well to get those same advantages. libgi repository 2.0. This is more of a chore to make sure that PyGObject is using the latest libraries. libgi repository was originally part of GObject introspection. However, it is now very stable and has been integrated with glib to improve the build process to prevent circular dependencies between glib and GObject introspection. The main change between the two versions of libgi repository is that it now uses GObject type instance as the basis of the type system, rather than a simple C-struct aliasing. The symbol prefix also was updated from G underscore to GI underscore. Various function arguments changed, and there were some modifications to the stack allocation. Philip Withnall started this work to port PyGObject, and Arjan Molenaar has picked it up to try to bring it home. The last part of centralizing docs is we need to move our API docs. So to do that, we need to combine and merge them into that PyGObject.gnome.org, and this would finish our centralizing of docs in all one place. So this is our news story. PyGObject is a great choice for building apps in GNOME. I also wanted to do a call to action. You can get involved with PyGObject. We're on GitLab at GNOME/PyGObject, and we would love contributions of any kind. Even while I was here in the conference, I heard people who said, like, hey, I'm experienced with this, or like I've thought about contributing, but I've never had a chance, and we would love your help. You can submit and help triage issues, continue to help us improve the docs, help us fix bugs and implement features. Even adding examples to Workbench is really helpful for tutorials. Build your projects with PyGObject, and come and even chat with us on Matrix at the Python channel. I also want to thank all the contributors who have contributed to PyGObject, especially over the last year, and special thanks to Christoph and Arjan who helped maintain PyGObject. You can check out these slides on my GitHub account at danyaw/presentations. And thank you. I'll be glad to take questions.
Hey, I was curious about the event loop integration in async IO. So is it actually having the glib event loop like take over the normal async IO event loop? Is that how it works?
Let me go back. So your question was, is it having async IO take over the glib event loop?
The other way around. Well, either way. How does that work? Because obviously I would think that you would not be able to call GIO async, like any of the async, like glib or GIO functions, if you're using the async IO event loop. It just won't know how to manage them, but maybe, I don't know.
So it uses the G main loop. It's kind of like a minimal, it's actually, I think Benjamin did a really nice job with this because it's kind of like the other things we had before were very heavyweight. I think this is very kind of like a small implementation, but it has full functionality. So it uses the G main loop to drive the async IO event loop. And then that unlocks, things like us awaiting the GIO async functions.
Okay. Thanks.
All right, so I have a lot to say, so I'll have to try to keep it like condensed. But I'm concerned about like several subjects. I'm very happy that there's like improvements coming to the documentations. Can I expect to go on a website and read documentation that's only Python without having to read documentation for the C API? Because right now that's kind of like required, and that's kind of holding me back in implementing, in using the full GTK and GObject API, because I don't feel comfortable enough to delve, like to go deep inside like those C APIs. I mean, there's a reason why I don't code in C and I code in Python instead, is because I don't have like the C skills. So yeah, it would be, and also I've been experimenting with like Qt recently, and I've been really impressed with the state of the documentation they have for Python, which they built from the C++ documentation. One thing I particularly enjoyed was the amount of like code examples they have, and I would like, I mean, if there's a way to have the same thing in GTK, I mean, it would be so wonderful. Another point is like auto-completion, like in your editor. So there is a method for auto-completion. It was for Vim. I wrote it. I since abandoned it. So I've stopped using it. I'm not longer like aware of like any current options. I'm using like VS Code right now, and I don't think it's like has the correct auto-completion, but is that something I could expect like in the near future? Because as I've been saying, I'm like kind of on the fence right now between, I'll have to migrate to GTK4 at some point, and I have to choose between going GTK4 or maybe switching to Qt. So that's the question right now.
Thanks so much for the questions. So if I'm going to summarize, I think the first question was about our API documentation, and is it possible to in the API documentation to see Python code examples rather than C examples in the documentation. We've come a long way in the last year with the documentation, so centralizing it and moving all these tutorials. I think that was also a big pain point when I was starting with GTK 6 years ago. You're looking at API documentation and you're not familiar with C or the GTK API in general, and then you're trying to write Python, but the example code in there is in C. That is how our API docs are still like that, so they have C examples in the API docs. I think one thing we've done by integrating the tutorials is it does provide a lot more examples of what to do all in one place. I don't think that fully fixes that issue. I agree, it'd be really nice to have Python in the API docs right along with the API definitions themselves. But currently that's not supported. If anyone has any cool ideas on how we would make something like that happen, I think that'd be great as well. And then the second question was about
auto-completion.
I think about code completion in VS Code and other IDEs. So a lot of IDEs, including VS Code and IntelliJ and others, support adding in stubs. And if you have a environment for Python set up, you can pip install PyGObject-stubs, and it has stub definitions for most of the modern GTK APIs. So you do get code completion in your IDEs. So that is supported right now, and it works pretty well.
So a quick addendum kind of on both of those. The GI doc and the stuff that predated it, we do have the ability to mark what language a code example is in. So if we want to really think about how just kind of going back to the beginning of GNOME, one of our big selling points was always that we're not enforcing what language people want to use and write in. We're very encouraging of a lot of languages. So, there is a precedent that we want to think about writing our code examples in multiple languages upstream in the repos. Some upstreams may be more amenable to that than others, but I know for all the libraries and stuff that I maintained, if someone wants to come add code examples, first off, that would be great. And if you just tag them with the right language, and then we can filter them out when we generate Sphinx documentation, et cetera. So that sounds like a great thing we should do. The other thing, which it sounds like there's this PyGObject stubs, Builder will look at if we have a Python language server available, and it will set all that up automatically for you. But it sounds like there's more we can do. Should we be working on a Flatpak SDK extension for PyGObject that includes all these batteries out of the box? Because if we do that, what I can do from the builder side is we'll just add the SDK extension to the Python project template. So it will just automatically download the extension. When the pipeline runs, it'll find the language server if it's in the SDK extension. And if we have the stubs installed with that, we should just get auto-completion and everything out of the box. And that's really our goal with Builder, right? We want it. We don't want you to have to do anything to set up your build environment. It should just be clone, start going. So I guess my question there is there anything we can do to collaborate on to make that sort of problem no longer exist?
I think that's a really good thing for us all to collaborate on. I think Builder already provides a really great experience if you're building an app, or if you're building a new app, to get a template for Python and other languages to get up and going very fast. So if there's other SDKs we need to add and bundle with Flatpak to make the experience even better, to get autocomplete or other things, I think, that'd be great for us to work on that as a community. I totally agree.
Okay, any other questions? Okay, thank you.
Thanks, everyone.